Hello and welcome to my channel, the channel of Captain Obvious. So today we are going to work on something which will allow us to learn Gradle build tool. So basically Gradle build tool, it is there. It's quite a complicated build tool for building Java applications, or more or less any applications you would like zipping, unzipping, compiling, whatever you want to do. The problem with Gradle is that although there is training available, including free training from like Intro to Gradle, the Gradle itself is quite complicated. As well-known Java and beyond guru Bruce Eckel said, Bruce Eckel, in his article, The Problem with Gradle, that it is useful to know the Kotlin language for actually understanding what Gradle does. And the problem is, how do we learn Kotlin? Because you don't learn such languages by just going through tons and tons and tons of manuals forever. So my idea is a hands-on approach, just to check how different things works. And obviously, there's a new approach for studying languages called Koans. So for example, Kotlin Koans, the idea is that you have a set of exercises which teach you something, and you have preset task with to-do function which is not implemented, and here you have a theory which you can follow. So can it be better? Yes, it can. You can actually start your IDE of choice, for example, Intellij, and Intellij, which is starting on my second screen, sorry about that. It has a plugin called EduTools. So let the Intellij actually start. And it takes surprisingly long. Yeah, it's finally starting. So the way it works, the problem with Kotlin Koans is that you don't really want to do such things from a browser. It's probably good when you are doing it from a library or something, but it won't save your progress and stuff. So instead, maybe if you log in some way, then it will, but I'm not sure. Instead, you can use a plugin called EduTools, I think. Control-Shift-A, EduTools. Oh, actually plugins. Yeah. You go to plugins in Intellij. Why is it stuck? Let's see. For some reason, my machine is going a little bit slowish. That's interesting. That's interesting. It's like something is affecting my connection. Okay, let's actually see what's going on. So maybe there's a network problem. Maybe there's a network problem. Because as we can see, neither CPU nor memory are really used. So if you go to the list of plugins in Intellij, you can see that I have EduTools installed. What it does, it creates this beautiful thing here. Yeah, this one, which is called Learn and Teach. And there you can browse courses. And this plugin allows you to connect different platforms with courses, like JetBrains Academy. I'm yet to actually join and check it out. I'm quite convinced that one should be quite fun. Community courses, that's the one we are doing. Oh, this would be interesting. This will be very interesting, and this is fresh. It's just December. It's a New Year present. This is interesting. So we'll do both. We'll do both. and other platforms like even Coursera. I think this one is also from JetBrains. Oh, sorry, from Intellij guys, but we'll see. Well, we can actually check it. Slow. It's Svetlana Isakova, but yeah, JetBrains. Yeah, and these guys, but that's it's JS and Python. That shall be interesting as well. So I've done some exercises in advance. Actually, I had a problem with my graphic card, so I had to change it. And my previous stream didn't actually get recorded. So the way it works, we just will start from here. If you want, you can, of course, go from the very beginning. So this exercise is expected to teach us about nullable types. All right, whatever. So we have a function send message to client which has 1, 2, 3 attributes. I'm not sure what this question mark means, but obviously we'll learn it from here. This one we don't need. Which keyboard do I have? Oh, of course, it's Spanish. So Java interpolation attempts to access a member on a null reference of a platform type. Okay, what is it a part of? Nullable types and non-null types. Kotlin's type system is aimed at eliminating the danger of null references from code, also known as the billion-dollar mistake. Okay. So basically we are going to learn how to solve a null problem in Kotlin way, or how to probably even prevent it. So yeah, parented the language is aimed to eliminate null pointers. It will be interesting to see. Okay, basically here are the ways we can have null pointer. Yep, different ways. This ones you'll more learn from experience, I'm afraid. I don't think it's possible to remember everything which can happen and which could lead to null pointers. That's why they happen actually. So, and obviously calling to null reference. Generic types for interpolation. Yeah. So yeah, in Java you can add nulls to generics. Yeah, that's all actually quite obvious. And this one I like. I love this one. Other issues caused by external Java code. So yeah, it's like 20 plus other issues. So basically, don't call something which is null, and be careful with collections or objects which might be not initialized or might have fields which haven't been initialized yet. So in Kotlin, the type system distinguishes between references that can hold null and those that cannot. Okay. So in Kotlin you cannot have null in a variable unless you tell explicitly that this variable can hold nulls. So if you go here and you do something like this, how do you type strings there? Oh, it's actually like this, right? Right? And if I do that, yeah, it should fail at compilation phase. Yeah, but if I add a question mark here, the very same will pass. Interesting. By the way, the way I did it is PSVM tab, and the way to learn it is Control-Shift-A. So that's called live template. Control-Shift-8 is the most useful and probably the only shortcut you really need to remember, because if you know Control-Shift-A, you can find everything else, everything and anything. So this method called send-message to client has attributes to client and message which can be null, and mailer which cannot be null. And we have the client class which has which accepts personal info attribute, which is nullable in its constructor, I think, because I didn't yet learn the classes in Kotlin, but it looks like Java. And personal info accepts email in its constructor as a string. And there's also interface mailer, which has a send message, which defines send message function to be defined with non-nullable strings of email and message. Okay, let's see this one. The only part I don't like about this plugin is that I don't know how to increase the size of font here. So sorry guys, you'll have to bear with me. Nullable types. Okay, so this part we did. So we need to rewrite it so it has only one exception instead of this expression, instead of this method, which has three nullables, two nullables and one not null. But this is already done actually. This is already done. So if client equals null and or message equals null, return. So they don't want three if expressions. Then we create this one, and if personal info equals null, then we return as well, and if this one is null, we return as well. Okay, so not the best exercise, but basically it's just refactoring, to be honest. We just paste it. Let's try not to create the bicycle. Did it copy nicely? No, I didn't. And of course, this is more kind of Java-ish style. So that's why they have all the Koans here. And this will be, is it this way in Kotlin? That's the other way around, right? I think in Kotlin it's the other way around. That will be email of type string. Okay. This will be as well. I think semicolon is not needed. So this is client with personal info. And the problem here is that I don't know how to access fields, how the fields work. So I would assume that before I start implementing the get method here, I would assume that maybe in Kotlin you can just access fields, and maybe if the field has been defined already here, it can just be used as a podger. Okay. So okay, that's fine, because what it actually says is that the problem is that this one might be null, but this one cannot be null. So we can either do maybe that or that, I'm not sure. Yeah, we can do that. Or such and such. Let's see. So I need to, to calculate this one, I don't need any data from here. So I could move this one here, and right, and I could just merge these two, right? Okay. Email that also comes from personal info. We can actually do it like this. Oh, of course, sorry guys, my bad. Seriously, okay. So this one is not needed as well. And this one, that's not the best if too many things. Okay. Else. Okay. Smart costing to string. I will just brute force it because I think there's a much better way to do it. Let's see what IntelliJ. Okay. So apparently this one dictates that it will be not null. Okay, cool. Because we know that it is not null. Now let's see personal info. Why is it? Oh, because when we create the client, personal info might be null. And that makes it a problem. So if you go here and we check again, I want to see how we use this one with objects. All right, can be set null. So what exactly is wrong about this line? So yeah, of course. So the client might be null, so that's why we cannot just go and call it. So the way I did it was incorrect, and we're going to redo it. And this time we will actually think instead of brute forcing. That wasn't. Yep. Oh, this is a nice feature. Convert code from Java. Sorry. Java is a motorcycle and a coffee, and Java is the language. So let's see. It has been already converted, and the goal is still to have only one if expression, right? How would we do it? We have, but that's not fair actually. That's not fair. So we need to delete it and put as Java because otherwise it's half a job is done. That's not interesting. So this one has to be deleted. This one, this one, this one, this one. So basically, oh yeah, and this stuff like. Okay, that's better. That's of course strong. That's better. So personal info, we will be getting it from an object which can be null itself, and personal info can be null. but if we put a question mark here, it will pass, because the code already knows that client cannot be null. If you move it here, it will fail as we did as it failed in the beginning. The problem is that now we're checking personal info for not being null, and that's the real point of this exercise. Now string can be null, and email can be null. And only then. So basically, these two variables, they depend on. So we get personal info from client if it's not null, if it will only work if it's not null, and we get email from personal info. So it's like a chain. So what we should do instead, and obviously we sent a message which should be also not null. Let's see if Kotlin allows us that. Client okay. That's not the best way, but this way we don't need this one and this one. Now we can do that. Why don't you like why don't you like oh, because it's nullable. It's sent message, but the email, it's actually not nullable at this point, because we would have returned. So technically email is not exactly nullable. What are we allowed to modify? Because I can just modify this one to make it accept. No, I don't want to modify. Actually, I'm not sure how it will work in Kotlin, but maybe if I do it like this, it will accept. So I cannot make this thing nullable because because this method doesn't have a nullable. Okay, I see. So yeah. So apparently there's something called what was the way? So we can replace with save call. No. They're asking me to rewrite the following code so that is only has one if expression. I have one if expression. The problem I have is that email is not null here, and we are trying to make it nullable, but in this case, if I make it so we have three objects. Do we have anything in the examples of like chain? Okay, checking for null in conditions. That's why you probably should read manuals before you start coding. So we can check, okay, if B is not equal null. Okay. Okay, so save calls. Kotlin has an option of save calls. So if b is not null, only then we'll call length. If a is not null, only then we'll call. We'll actually check, not call. We'll check field length. So save calls are useful in chains. Oh, this is actually easy. This is actually quite easy now. Because this one will also only be called when it's not null. And then we have else operator. Let's see the else. Let's actually read the whole page, just in case. When you have a nullable reference b, you can say if b is not null, use it, otherwise use some non-null value. So yeah, that's similar to Java. So if b is not null, then we give length, then we return length, otherwise we return -1. That's how it works. Yeah. This is beautiful, but reminds me of Perl. You'll have to practice this stuff a lot till you remember it, or maybe like 10 times. And the expression to the left, okay, that's easy. And that's full node string. Throw and return. So basically, oh, we can also return stuff. Okay, and we can throw exceptions. This is beautiful. This is good. The third option is for null pointer exception lovers. Anybody who actually loves null pointer? Perverts. The third option is for NP lovers, the not null assertion operator. Converts a new value to a non-null type and throws an exception if the value is null. You can write okay, so we can make it actually call length even if this one is null, and then we'll get a null pointer. There might be scenarios when this one is useful, like the code around expects null pointers and there's business logic attached to it. I've seen situation like that, but this is not right, guys. Thus, if you want a null pointer exception, you can have it, but you have to ask for it explicitly and doesn't appear. Okay, cool. And the last but not least, two last things. Save costs. Okay, so this is a nullable int. And okay, so this will only work if a is an int. And we also can have collections of types which are not nulls. So this one shows it's nullable, might have nulls. and then we filter not nulls. Okay, that's understandable, although there was a question. This one I want to actually see how it will work. I want to see this one. This one obviously gets deleted. I will rewrite it again. Okay, Control Shift F10. Okay. Okay, this one. Actually, I will just comment out everything. Null and 6. So yeah, here well, okay. I thought it's both of them are B, but actually this one is A. So for this one, there is no point to do the safe call, and this one will actually output null. To be honest, for some reason I thought that it won't call the println, but it will call apparently, but it will call maybe with this value. Okay, we'll learn it from experience. Okay, and this one we don't need. Now we take this code again, and we see. So instead of all this stuff, no, I don't want to convert to Kotlin. And so we have client, which can be null, and we have personal info, which can be probably null, and we have were they using vals? Yeah, they were using vals. There's a difference. I think val is local. We'll first just clean it up a little bit, and then we'll go again and fix everything what's left. All right. Now, obviously this one I don't need semicolon, and here I don't need. I just can't see the code which is not formatted. It's disgusting. So client can be null actually, and personal info can be null as well, right? Okay. And personal info can be null, and obviously email can be null. Okay. So let's see. So yeah, this will work most probably, but the problem is now they want one big if. Of course, I could make it like this. Okay, then I don't need this stuff. Sorry, I don't need this stuff. And I don't need this stuff. No, this stuff I need, it's variable, but this stuff I don't need. Okay. And now this one cannot be null anymore because we are checking it here for null. So we can push it through. I wouldn't say enjoy it. There must be a better way, but in real life, what would I do? In real life, one if should be okay, but actually in real life I can do it like this. right? Because what does it do? This stuff only checks client for not being null, but I don't care because it is checked with, what do we call it? Safe call, whatever. And email, I don't. So this one can be null. So I was checking it in Java for being null, and personal info could be null, and I was checking it. So, but I don't need all this stuff. So to be honest, it's as simple as if email not null, we do that. And what was the way they did it? Oh, just that message. Where was the message coming from? Oh, and okay. So apparently that might work. So it's not enough just to know some Java to make this stuff work. You need to read the documentation. Thanks God or thanks JetBrains that you can actually go and read just a small amount of information. Yep. So what didn't it like? Oh, I have no idea what this. Let's do it again. What exactly don't they like? Oh, now it's correct. I want to see how they fixed it. Oh. Yeah, true. Basically, we don't really need personal info because why would we need personal info? We only need it for an if. So to be honest, that was like that. Okay, still should work. Two-liner, actually more concise than their code. The important thing is to stop at some point because I don't want one-liners to be like 300 symbols long. So yeah, this is as we want it to be, and this is all nice. And yeah, yep, that's all good. So let's go for the next one. Nothing type. Interesting. So let's first read. Nothing type can be used as a return type for a function that always throws an exception. When you call such a function, the compiler uses the information that it throws an exception. This part I don't understand, the compiler. Yeah, I'm not sure what the author wants to say here. Specify nothing return type for fail with wrong h function. Compiler assumes the h can be null. Okay, let's see if that's not too long. Yeah. Throw is an expression in Kotlin. So you can use it, for example, as part of an Elvis. Okay. The Elvis was from the previous one. The type of the throw exception is the special type nothing. The type has no values and is used to mark code locations that can never be reached. Oh, here it is. So this function will never return. This function is set to break. Let's see, when you call this function, the compiler will know that the execution doesn't continue beyond the call. Okay. Another case where your main count this type is type inference. The nullable variant of this type, nothing, has exactly one possible value, which is null. Okay, if you use null to initialize a third type and there is no other information that can be used to determine a more specific type, the compiler will infer with nothing type. Okay, so if I set x to null, it will have type nothing, or if I set this one to null, it will have list of nothings. Interesting. Okay, whatever. So this one will be easy because basically this one is expected to return nothing, because this one will never work, and then it will fail. And then we are going to check, yeah, that's obviously correct. Yeah, obviously nothing to, no difference as such, but I was more interested in this part. Oh, they already have main. Whatever. So I just wanted to see if that will work. So for vals it works. What about vars? Oh, but okay, I understand my misunderstanding, although it's weird. So that wouldn't have worked, but that will work, I think. And if we put a breakpoint here, so basically when we are asking compiler to actually infer the type, when we are not telling this is a string, then you can assign nulls to it easy. But if you're telling it is a string, you must tell that this string might be null, because otherwise it won't compile. Okay. How do we debug this one? Yeah, this one, and we have x. And how do we I want to check type of x. I don't want to trust the guys. I'm sure everything is hanky-dory, but Kotlin type of Stack Overflow is okay. Can I do this thing? Alt insert, right? X is nothing. So in this case, x is not nothing. But if I remove string, what will happen? Still not nothing. How does equality for nothing works? Kotlin check type of variable nothing. Okay, people are confused. Me too. Okay, whatever. We will just pass on because it's probably a little bit advanced, or maybe I'm doing something wrong, but that won't make me much smarter. if I pass this on for now, I'm sure it will come later. So we have one last one to solve, lambdas, and then I'll take a break. So this one, it's about lambdas. Lambdas is, yeah, plain old Java 8. Lambda expression, anonymous functions are function literals. Okay, so apparently Kotlin has anonymous functions as well. Good. Function literals are functions that are not declared but passed immediately as an expression. All right. So apparently this one looks like Java, lambda from Java. So this will probably return the longest, either the strings or okay. So it will return the result of this thing, and the result of this thing will be a boolean, I think. Yeah, so that will give us a boolean from the compare. So max is higher order, and we'll get a strings, probably variable, and not probably, it is variable, a variable, and it will get a boolean here. So A and B will be called using function literals construction, and they will return a boolean. Okay, so you can also define lambda expression like that, but you don't really need it. You can use it this way. Okay, so you give it a name as normally. Here, instead of just the type, like we had string here, you give curly brackets, just normal brackets, round brackets, and types via comma, the ones you're going to use here. And then you use this arrow, and you define the returning result, and you use equal, and you put this, how they call it, literal something? Function literal, yeah. So lambda expression always run, that's clear. That's clear, that's clear, that's clear. If the inferred return type of the lambda is not unit, the last or possibly single expression inside the lambda body is treated as the return value. So you don't actually need to to say return, because this value will be used as a return. So here we didn't. It's a full-blown function. It's a function literal, but you don't need to declare that it returns this stuff, because this stuff is the last expression, and that's used as a result. The last or single expression inside the lambda body. Sorry. Passing trailing lambdas. How much stuff is here? Oh, there's a lot of stuff actually. There's a convention. The last parameter of, if the last parameter of a function is a function, then lambda expression passed as the corresponding argument can be placed outside. The last parameter of a function is a function. Then a lambda expression. This is not a function. Passed as corresponding argument can be placed outside the parentheses. Oh, so we don't need those curly brackets around this stuff, because the last parameter of a function is a function. Maybe they refer to this one. So if this one is a function, then we don't need curly brackets. Yeah, this one is also a function which returns println. But oh, we can probably we can drop these ones. Okay, that will be interesting to see. I don't exactly understand it. I have some feeling that maybe this stuff can be dropped and this stuff can be dropped, but we'll see. I hope IntelliJ will suggest me that this stuff is not needed. I hope so. Implicit name of a single parameter. So the lambda expression has only one parameter. If the compiler configure the signature out itself, it is allowed not to declare the only parameter and omit this one. The parameter will be implicitly declared. Okay, so this one can be omitted, so this one can, oh. Okay, so this is actually lambda or functional literal, but we don't need, yeah. This looks obvious actually. Actually, let me first check the examples because reading text is boring and inefficient. So, oh, I guess this is a lambda. Yeah, and this is a lambda. This is actually a function, but otherwise the value, or maybe, no, it's just a comparison. It's not a lambda. Oh, you can explicitly return a value from the lambda using, but you could make it lambda. The qualified return syntax. So we can return should filter, but otherwise the last one will be returned. I don't really like these examples. I think they are an overkill. Like this one, the should filter is already the last one. So if they put like another value here, like value b, and then should filter could make some sense. Okay, so we can do it like this. You can filter, and filter will get a function. And we can sort by this one. Okay. This is a lot of stuff. I'm not really used to lambdas at the moment. I know the theory, but I don't use it often. Because I work in enterprise. And sometimes we have to use all the versions of Java. Which is most of the time. The structuring and lambdas is described as a part of the structuring declarations. So this is a function, but it has no name. So comparing to this one, yeah, it has no name. Okay, so yeah, anonymous functions are cool. and everything goes the same as regular functions. But we don't need to declare the parameter types. That's good. This is a ton of information. This is like a lot. Okay, I'll just quickly scan through other stuff, but closures. Okay, back to JavaScript, right? Lambda expression can access its closure, which includes the variables declared in outer scope. So yeah, this one can accept this stuff. Okay, this is big. Functional literals with receiver. So I have no idea what the receiver is yet, but apparently it matters. Okay, so apparently this one becomes, this object becomes this. Ouch, sorry. Let's see. So other plus other. Okay, so this refers probably to this one. And this refers to other. Alright. Lambda expressions can be used as functional literals with the receiver when the receiver type can be inferred from context. Type save builders. So we can do it like this, and we can do it like this. Create the receiver object. Okay, so we have class HTML with body, and we have HTML function, which is using this, how they call it, functional literal with receiver, and it will return us HTML. So we create HTML. We actually create it because and then we pass the receiver object to the lambda. Okay, and return it. I will have to work on this one. I don't exactly understand it, and you can see it, I guess. So let's see what actually is the task here. Pass a lambda to any function to check if collection contains an even number. Sorry. Okay. It's like this.